Good morning, good afternoon, good evening, good whatever it is, wherever you are today. I'm Ali Amagasu, and you're listening to the latest episode of Cloud Unfiltered. I am here with my co-host, Pete, as usual. Hey, Pete, how are you doing?
Hey, Ali, it's going well. There's an ice storm outside. I'm sure you're dealing with the exact same thing in Southern California right now, but, carry on.
I won't turn my laptop around to show you how beautiful and sunny and cloudless it is.
Not if you want me to continue to co-host, you won't.
That's right. I do appreciate it. It's nice to spend some time with you today, Pete. And the other gentleman who's spending time with us today is Arpit Joshipura. He's the General Manager for Networking, Orchestration, and Edge/IoT at the Linux Foundation. Welcome, Arpit.
Well, thank you. Happy to be here.
Thank you so much. The reason I asked you to be on the show is back in late January. I got an email from the Linux Foundation announcing something called LF Edge, and I was immediately intrigued. I thought, this sounds like a new foundation. Why do we need a new foundation for edge technologies? Maybe I'm misunderstanding if it's only for edge technologies, but that sounds like what it's for. So I had questions around that, and I really appreciate you coming on to answer some of those.
Sure.
So my very first question is, what drove the foundation to establish LF Edge?
There were three primary reasons that we looked at creating what we call an umbrella of edge projects. The most important reason was edge itself is ill-defined in terms of the scope. Where does it start? Where does it stop? So that's kind of the first thing. How do you define it? Where do you draw the boundaries? Even if you identify the boundaries, there are tons of projects, specifically open source projects, that exist today. And the market is extremely fragmented. That was the second driver. And then the third one was, if you need a solution today, you have these vertical silos from an industry perspective that are trying to solve this. You have, many flavors of a cloud-based solution, right, led by public cloud players. You have many flavors of an enterprise edge solution, led by several enterprises. You have solutions for the edge starting with an IoT perspective. And then, of course, the last but not the least, you have the telecom or the telco carriers, whatever you want to call it, also playing a role in the edge. So our goal at the LF, or the Linux Foundation, was to create a unified open source framework and entity that can bring these market verticals and projects together and create common plumbing and common APIs so that you can have those proliferation of edge apps that we are all dreaming about.
Interesting. Now, I know there are a bunch of, anchor projects that you're starting off with. Were these anchor projects previously just, where were they falling? Were they under CNCF or just the Linux Foundation, or?
So three of them were under the Linux Foundation, but they were run as a separate project. So if you may, the first one being EdgeX Foundry, which was a IoT framework for the edge. That is, almost 2+ years of work that has been done on that. Tremendous project, again, focusing on the framework. There was another project called Acrano Edge Stack, which is about a year old, again, primarily focused on two use cases, a telecom use case and an enterprise use case for the edge, but with sophisticated blueprints that kind of test end-to-end systems. And then the third project under the LF was something called Edge Glossary. To my earlier point, right, if we cannot agree on a common language, and I'm not talking, Yang and Tosca models, I'm just talking simple, definition of what is an edge and the terms.
Terminology, right?
Yeah, just terminology. So, there was a project like a Wikipedia-style open edge glossary project that was already part of the Linux Foundation. So we took those three projects, put it as anchor projects under the LF Edge, and added two more new projects. One dedicated to home edge, where a lot of the home devices as well as services and applications need edge compute. and another one focused on on-prem edge, which is really the software and the edge virtualization engine that comes with IIoT and factory-based devices and equipment. So those 5 made up the anchor projects, and so it's a combination of existing plus new, and we have a great pipeline of projects that are wanting to get on and harmonize as well.
That's what my next question was going to be. Is the goal to grow the number of projects you have in there, or is it simply, or is growth not necessarily important? It's simply you're going to deal with projects organically as they come along, and if they meet your criteria.
It's mostly very selective criteria, but more importantly, there's a process on project induction that Linux Foundation has followed for quite some time. LF Edge is a welcoming community and an open community, right? So we will always be on the lookout for projects that add value to the scope. And again, I'm going to draw the line where the start of the edge is, again, not the hardware and not the connectivity. So we're not talking Zigbee and Bluetooth and Wi-Fi and those kind of things. And it is not centralized data center, right? Data centers that are hundreds of kilometers away that is serving an IoT application is not an edge app, right? The definition that the community is kind of zooming in on is mostly around if there's an application or an IoT device that requires latency response that is in the 5 to 20 milliseconds of range, where an app survives, right? So they could be connected cars to AR, VR, to 360 videos, to healthcare, to several IoTs, etc., where you actually benefit from bringing compute and storage close to the application as possible, starting with the central offices or smart COs, as we call it, or edge cloud, many terminologies again, all the way to on-prem gateways and software that goes inside the hardware on the device itself. So that's the scope of projects that we will be on the lookout for. It's not going to be like any project can come in, right?
Right. So do you have a strict list of criteria?
Yeah. So we are looking at it from a vertical perspective, where the verticals that are predominantly benefiting from the edge application and the edge proliferation of edge compute and storage, starting with the industrial, obviously industrial and manufacturing sectors, the oil and gas sector, commerce, retail, then transportation, fleet. Telecom obviously is a big one, and its associated apps, especially as technologies come together. We're looking at smart cities. There are projects that are looking at it from an agriculture perspective, etc. So vertical is one dimension where criteria is important. The other dimension is does it simplify the ability to do lifecycle management? Let's ask a very simple question, right? These open source projects thrive when the software that goes in it is not terribly differentiated, right? I hate to call it the plumbing, but that's what it is, right? Which is, how do you start, stop, load, boot, reboot, upgrade, log, right? How do you transfer data that comes at it from, an ARM, Intel, Qualcomm? How do you make it abstracted? I mean, things like that. How do you connect to a multi-cloud environment, right? What APIs do you expose to the apps? These are things that the project aims to solve, because we don't want every application or every device or every cloud to reinvent the same plumbing. And that's kind of the high level notion. I'm going back to why, but just a little bit down. That's kind of the intention.
That's okay. That's helpful. Pete, as I listened to Arpit's answers about first off the why of the project and also things like the definition of edge, I imagine you have questions.
Yeah.
Or at the very least, comments.
Well, a couple of things I wanted to ask about there in terms of what the group's opinion is about some of these things now, right? So you have kind of classic IoT where you have all these devices generating data and then ultimately sending that data today primarily to some data center somewhere.
Mm-hmm.
And then you kind of have the notion of, and you guys even have this in your diagram that's on the announcement, you have this notion of that there's something closer to where the data is being generated that is filtering that data or taking actions on that data in some way. And in Cisco product nomenclature, that's kind of what Kinesis does. So then there's the kind of the notion of, okay, something in that ecosystem, whether it's a device or whether it's that filtering and store and forward mechanism, makes a decision that, okay, I need some compute to go make a decision on something. And then there's the, okay, how do I discover what my choices are to go send something out to go run some piece of compute? I always kind of think in that scenario, it's the discovery part that's difficult, given that you're now not in a central data center, that has certain, like you don't have trees falling on compute units in data centers the way you do, like if you're trying to choose like a cell phone tower or something like that. I guess, so in my perspective, the hard part of that is discovery. Am I wrong about that? Or what do you think is the most difficult part of that whole scenario that I just laid out?
I think that the most difficult part, so discovery is absolutely important because most of the times the device may not even be connected, right?
Right.
And so, yes, I agree with that. I think if you step back a little bit and look at the end-to-end services that an application is going to drive and the value that is going to create. So, if let's say an AT&T or a Verizon is going to sell an IoT service or sell an edge app service, there's some SLAs that come with it. And 99% of those apps / devices cannot have any manual touch, right? Because these are not cell phone registrations where you can actually go to a store and say, I'm good, and I can wait and then I'll be there for a year. These could be on the network, off the network in 10 milliseconds. It would kind of do things in a very different way, right? So the most important thing that we are doing is kind of the zero touch, where can I get through the front end of, even before the device discovery and orchestration, and like, can I get a zero touch provisioning and the front end of that app as well as the device standardized? And that is through either APIs or that's through code that is starting from the cloud into an edge, into a device, lightweight, Kubernetes light, not even like a micro container type things, right? So it's a very lightweight version of software, right? Given the memory limitations and things like that. That's the first step. The second step is once they are active and once they have the life cycle going, what is the use case that they are looking at? And then the most complex problem is, again, I will always say discovery will always come up, orchestration will always come up, plugging in and APIs will always come up. So those are classic problems. But if you look at the architectural problems, what the community is solving is really around the specificity of a blueprint. And what I mean by that is every environment in every vertical today is different.
Right.
The use of a sensor or a thermostat or a car or a phone is completely different. And we know that. But can we abstract the devices and the apps in such a way that lifecycle management, data storage, discovery, orchestration, logging, booting, things like that are the same, right? Does it matter if you are serving, a sensor or a thermostat? Does it matter if you are in the industrial zone or in the utility oil and gas or in a retail setup, right? What is different is how much connectivity you have, how much storage compute you have, and what's your workload / app that's running on it. right? So that's the intent, and that's the complex part, right? Is how do you narrow it down to the blueprints that can be that are the most widely used, most successful blueprints in each of these verticals.
So what are the life cycle phases that these devices that are generating the data would go through? And then based on those life cycles, which ones are you to the point where you're creating classes of devices like you just use, phones but presumably what you would do is, once you've defined the phases, you're going to find classes of devices that use those phases in similar ways and be able to abstract on top of that.
No, actually what the team is doing is it's a layer of abstraction that is making the projects, and this is, EdgeX Foundry is leading that. And what that is doing is the lower layers of software is making it hardware independent, silicon independent, connectivity independent, OS independent, all right, and even language independent. So an app could be written in any language, Python, Java, Go, it doesn't matter. All of those are abstracted out, right? So that the code that glues everything together does not need to know about the specificity, right?
Okay.
The blueprints come at it from an Acrano edge stack perspective, where there are about 19 blueprints that have been approved by the technical community so far. And those blueprints really say, if you are in a factory, right, that wants to do these things, then here is a proposed blueprint, which means here's kind of the 2 or 3 hardware setups, here's the software, here's the stack, here's how you stitch it together here, and it comes, tested as a reference solution.
Okay, so are the blueprints primarily reference architectures then?
Reference
that contain all these different components?
Architecture, reference implementations and solutions, right? That come in tested, yes.
So factory is one example of blueprint. What are a couple of other example blueprints?
Factory, remote edge, site routers, routers below base stations that go into it, smart cities, 5G. There's blueprints on the RAN. So as 5G comes in, can you put enough of a blueprint below a stack, below a base station? And
do the blueprints overlap? Because it would seem to me that smart city and factory might overlap with 5G.
They could overlap, but a blueprint is self-sustaining. Okay, so there might be some overlap, but in general, when you look at blueprints, there is a very detailed community document that defines what a blueprint is, exit entry criteria. You could find it on, Acrano, lfedge.org, wiki Acrano, and you should be. So it has all the criteria on what a blueprint is, what are the exit entry criteria, what constitutes it, and how do you submit it. So
and maybe overlap was the wrong word. Do they stack on top of one another?
You can use more than one for sure, right? And
but what I mean by that is so 5G I tend to think of as that's a networking construct, and having devices in either a smart city or a factory might build on top of that 5G construct.
Correct.
So that's what I'm saying. So do they stack in that way?
That is possible. That in that example, yes.
Okay.
In the 5G example, yes. So anytime there is an intersection of the telecom, the cloud, and the enterprise markets, right? 5G being a classic example, right? Where one is serving, the other one is getting serviced. Yes, you can actually use a couple of blueprints to sort of talk to each other. Yeah.
Okay.
Yeah.
Now, like in terms of like membership and who's contributing and how many contributors, what's that look like in terms of who all is involved with this, and what's kind of the scope in terms of headcount on this right now?
Yeah. So like any other project, as you know, this is an ongoing TSC and a community for at least three of the projects. At launch, we announced with 60 founding members and almost 28 premiers who are part of the governing board.
Okay.
the most interesting dynamics that we have seen so far is that it is a cross section of end users and vendors, and it's a cross section between cloud, telecom, and enterprises. So and IoT. So give you an example, right? So you got players like AT&T, NTT, etc. Sort of from a telecom perspective, contributing the telco edge and those blueprints, right? Leading the Acrino project as well. Then you have the cloud players like, say, Baidu and Tencent, who are part of it, and they bring the cloud perspective and the cloud API and the unified connectivity, sort of visibility across clouds, right? The multi-cloud aspect. So that's them. Then you have the IoT players and the classic enterprise, like in terms of Dynamic or OSI Soft and things like that. You have your app developers like Mobile like EdgeX. You have obviously system vendors, the usuals, and then you have pretty much the entire. I wouldn't say entire, but you have the main three hardware ecosystem. So ARM, Intel, and Qualcomm. All three of them are collaborating, and that's the beauty of open source, right? This is independent of what each of them bring. They're all coming together, to create this shared technology, and then they will each build on that and innovate and differentiate on top.
Okay.
So that's kind of the high-level view. In terms of developers and in terms of the community itself, every member, right, is every day adding resources. So if you look at the TSCs and the lists of TSCs, it's growing. We're probably in the hundreds now in terms of actual developers contributing here.
Now, I couldn't help but notice when you mentioned cloud providers, you didn't mention the big three there. And I want to read back to you my favorite sentence from your announcement, which is the current edge market is heavily fragmented with multiple proprietary stacks for each public cloud. Correct. So are you getting contributions from AWS, Microsoft, and Google, or do you see some friction there in trying to get this going with the larger community if they're not participating?
So I would say we're getting good collaboration. So here's where it stands today. So today, if I'm an IoT app or an edge app and I want to use the public cloud, then I have to be either in the AWS ecosystem or the Azure ecosystem,
sure.
right? Both the software that goes in the device on the microcontroller, as well as the gateway, and obviously the cloud, right? And then if I am a global enterprise that is running that factory, and one of my factories happens to be in China, right, or anywhere else, I don't have visibility across these, right, because it's just right. So one of the big things that LF Edge will do is provide that layer of virtualization engine on the IoT layers, right? And then EdgeX Foundry has the mechanism to connect it to the various clouds. So now your APIs can get standardized, as well as you can get that visibility across. So Tencent and Baidu have, and if you just look at what has just happened, right? The Amazon and Microsoft were ahead on the game. We all know that. Baidu just launched their Open Edge initiative. If you're familiar with that, at CES earlier in 2019.
Okay.
But they just decided that they will join LF Edge and they will contribute that so that you can move the market much better and much more in a unified manner, right? So Tencent and Baidu are here. We have been talking to the cloud players that you named, and the specificity of APIs and the contribution to get that visibility is a motivating factor for all of them.
Okay. So Ali, I got one more, and then I'll I know you've got some other stuff that you want to ask as well. What about Brownfield? So, right, we've got all these devices that are out there now that are generating this data today, and certainly there's going to be some point, whether it's 5 years or 10 years, that there's going to be more devices deployed in some future span than we have today. But we have a lot today as well. So as part of kind of your design attitude towards this, are you trying to do this in a completely greenfield manner where you're not concerned about the current the current device ecosystem, or how are you potentially wedging the current device ecosystem into what you're planning?
Yeah. So as I said, LF Edge is device independent, hardware independent, OS independent, right? So the abstractions and the drivers that are required for current or future devices are all included in that layer of software that sits right above the hardware, right? And so every brownfield application or device that wants to participate and be part of this open system, they can plug in, have their drivers, and then you take advantage of this open source software. So absolutely, this is not like a new product, right, that we are all used to, where it works either in a brownfield or greenfield. It is built with a migration in place, where existing deployments, and this is primarily because the focus of LF Edge is not on the devices themselves. It's not on the hardware. It is not on the connectivity, right? All these radios, right? 10 to 15 different types. You can come inside a gateway any way you want, right? Low power, high power, Wi-Fi, Bluetooth, Zigbee, you name it. And those things are abstracted out. So yeah, I mean, it's mostly focusing on the one layer above the device.
Okay.
I love a good abstraction layer. Hey, I do have a question I've been waiting to ask. If I'm listening to this and I'm not a telecom, I'm not a major cloud provider, I don't produce IoT devices, I'm just someone from a regular enterprise, I'm an IT leader at a regular enterprise. How relevant is LF Edge to me? Should I be paying attention to it? Should I have someone on my team aware, at least keeping tabs, if not participating? Or is
Absolutely.
it not really something relevant to me yet?
Absolutely. So just like an enterprise IT CIO, in the last 5 years, 10 years of kind of what we have been calling digital transformation, is modernizing not just the processes, but all the IT apps, and trying to do like a hybrid cloud approach. In these selected verticals that I talked about, the IT and the operations staff need to really focus on what solutions exist in the next 1 to 3 years, right? They have loosely been kind of aware that 5G, and I sum it up very, very simply, like there are 5 converging technologies that is making Edge so interesting. The first one is obviously 5G, very low latency, very high bandwidth, at a very low cost, right? Brings up a whole new market of cars and all that. So automotive guys are really excited about that, right? We have consortiums like AECC joining LF Edge, right, from a automotive edge computing perspective, right? So we'll keep that in perspective. The second technology is microservices, right? So now apps that they are writing that are meant to be at the edge, right, with Kubernetes or with lightweight containers, extremely important. And that technology and that process, CI/CD DevOps process is quite mature, right, to utilize, right? So that's the second one. The third one is what I call hardware acceleration. So GPU, TPU, NPU, memory, compute. All of the hardware has really, really come a long way for these kind of applications. The fourth one is analytics and AI. And I don't want to use it loosely, but you can appreciate that when you can make local decisions on predictive maintenance of a device or a machinery, right, based on algorithms, right, whether it's done at the gateway inside a microcontroller or in the cloud, right, saying, hey, that device might fail, send a technician, right? That is a very powerful edge capability. And then the last missing piece was really the on-demand NFV, or end-demand network function virtualization, or really the edge cloud, which is what the telcos are bringing. They have an advantage of location, latency, and mobility. Let's face it, they are closest to the end user and the end app, and they make the fifth part of the puzzle. And that's why you have this at your disposal, and from an enterprise perspective, I have to pay attention, because I can change the way I do my services, and I can change the way I run my operations, right? Given a new set of technologies and services I can buy.
Great answer. So there you go, listeners. Whether it's immediately evident or not that edge is a part of your life, it is. And there are opportunities for those who are willing to stay on top of it and move further in their digital transformation journey. Now, Arpit, before we let you go, I want to first off ask, is there anything you wanted to tell us about LF Edge that we didn't ask? And then I'm going to ask you how you got into tech.
I think you covered Edge quite comprehensively, so I'll leave it at that.
Well, really, you did the covering. We just sat back and listened, but thank you.
Questions were good. Questions were good. Thank you.
So how'd you get into tech then?
Well, take a guess. It's the usual journey, right? Engineer by training, starting from assembly into software, hardware. And then I always believed, engineers who can do system architectures become architects. Architects who can speak become managers, and managers who can think further on become executives. And that's kind of where I am 30 years into this, and been in this industry for quite some time, just doing telecom, IT, enterprise, startups, paid my fair share of startups, and the usual Silicon Valley life, I would say.
Well, thank you for sharing that. I appreciate it. Before we let you go, I do suspect there will be people who will listen and say, hey, how do I get involved? What URL should they go to?
lfedge.org. And
lfedge.org.
And there's a form there at the bottom. More information.
Perfect. Well, thank you so much for spending time with us today. It's been a pleasure.
Thank you.
It's always nice to talk to you.
Yeah, thanks. We'll see you next time.
See ya. Thank you.
All right. See ya. Bye-bye, everybody.